Okay, so for the next step, I'm going to talk about the processes. For the getUID, okay, this is a function, just is a simple function that, okay, so you can basically check that what is the UID of the user that is basically is running this process, and the group ID of the user that is running this process, and basically the process ID, and also the parent process ID of this process, the current process that you have. Okay. And by the fork, you are going to duplicate the one process. But actually, you know the details of that. So okay, so it's just duplicating, and also you know about the return value of the fork. So the fork for the child returns 0, and this is the important point. And for the parent, it returns what?
Something different from 0.
Something different from 0.
PID,
But this something from different from 0 is the PID of the child. Okay. And we have also one wait function. It means that, okay, it's just wait, so we can suspend execution of the one process, waiting for the termination of the one of the children of the parent. Okay. And also we can collect basically the stat. And so the exit is just basically when we are going to exit normally from execution of a process, so we can use basically the exit, and also we can pass to the parent one status. This is an integer value, okay? And also we have a system function, and this system function is just when you are going to run. When you are going to basically pass a command to the shell that you are running basically your process, so you can basically use this system and then run some things on your terminal. And here, okay, so the next thing is we have different types of the exec. So when we are going to replace the binary file, one binary file with the current process, so we can use the exec function. Okay, so I'm just executing, and after a moment I prefer to replace the one binary file with the current process, so we can use exec. But we have different type of exec, but I'm not going to go to the details of this. But the point is that the difference between this exec is just passing the argument. The differences between the type of the exec is passing the argument and also processing the first argument that is just the binary file. So this is all about the exec. But okay, so let I give you some examples. I suppose it's much more clear.
Can you just repeat system? What it does?
System, yes. Okay, so if, for example, I'm running my process in a terminal, right? For example, in the bash terminal, and I need to run some things on the bash terminal, so I can basically I can pass my command to the system, and then I see some things. I see the output of that.
So instead of doing fork and then exec, I can use the system.
No, the system is just okay. I said okay. If you are going to run some things on the terminal, so I run my process in a terminal, right? So if I'm going to run some things on the terminal, so I can pass my command to the terminal, and then I use the system. But I give you the example. So it's just okay. So first of all, I give you the example for the fork. Okay, for the fork. Okay, so I suppose that is okay. It's clear that okay. So when we are going to create a one process. But so we need to use fork. So if the output of the fork is just less than 0, it means that okay, we face an error. So we need to handle that here. But if the output of the fork is just equal to 0, it means this part of the code is executed by the child. Actually, yes, it's written also. Okay, and okay, so I'm going to just collect just a set of functions, all of them together. So here I'm just printing out the get PID and get PPID. So here the output is that for the first one is just printing out the PID of the child process and the PID of the parent process. Okay?
Yeah.
And this part of the code, okay, so till here, just last, yeah. This part of the code is executed by the parent because basically the fork, here we handle it for the if PID is equal to 0, and this part is just when the PID is not equal to 0, okay? And again, I'm printing basically the PID, and this is the PID of the, this is PID of the parent, basically it's PID of the parent, and then my child, I'm printing PID. And why I'm printing PID? Because this PID is just the value that I stored here, okay? And this PID is PID of the child process. And after that here, so we block basically here in this function, wait. So we wait basically till the child terminate, okay? And after that, so if the child terminate and everything is okay, so by this basically, by this macro here, I'm just verifying that, okay, the child is terminated in a normal way. Okay? And if it's terminated in the normal way, I'm just trying to collect the value of the status. Okay? So by this function, by this basically, by these two macro. So you need basically these two macro, first of all, in order to verify that, okay, the child is exited normally, and after that we need another macro in order to see to collect basically the status. And this status is basically is the value that I just passed to the exit function. Okay? So in this way we find basically the first communication between the child and the parent. So child can pass a number to the parent, and this number is just something, this is a status, and is just numbered inside of the exit function. Okay. And we can collect it inside of the parent through this macro and printing out the status. Okay?
And
but okay, so but just okay, so I show you the
with weight and percent status, we are passing it by reference, so it is.
Okay, so with the weight, yes, with the weight. So first of all, we need, because actually with the weight, I'm saying okay, so the process will be blocked here.
Yeah, and you wait for a return from the child.
Okay, so first of all, I collect it here, and then after that, I'm printing out the value here.
Yeah, but to the weight you pass status not
yes.
by value but by reference.
By
so
reference.
that is it's taking the value of exit from the child.
Yes. And also it has one more note that you should note that okay, it only basically pass the 8 bits, the 8 low order bits of the status. Okay. So here, okay, I passed the 260. And so the something that I expect, so it's just not exactly 260, and it's just only the 8 low order bits. So if I verify here, that's just by. Okay, so this is the binary representation of the 260. So if you verify here, this is the 8 low order bits. Okay. But so basically this is the representation of the number 4. Yes? Okay. So if I pass 260, I expect that okay, I just collected because it's just representation of the low 8 bits to the status there. Okay. So okay, so this is basically parent process. This is the child, and from the parent, this is parent, and okay, so and this is the this is the child, and this is the parent that is okay. Is also indicating here, and this is the number that we set is just 4 because it's just representation of the 8 low order bits of the status. Okay.
In theory, I should exit with the low value, not with the in.
So yes, but I'm just giving
Okay,
example.
okay.
So you can basically pass
Because
everything.
it says put zeros and then the low order bit.
Yeah. Okay. So, but if I pass also, if I pass here, for example, if I pass also here 4. So also I receive 4. So there is no difference. I pass 4 or 260 because the representation is the same. Okay.
Yeah.
Okay. The next thing is just the system. So this is the system. Okay. So you suppose that I'm going to run. I'm going to see the output of the ls command inside of the terminal. Okay. So I can indicate my command here. This is ls-l, and then I pass it to the system command. Okay. So the system will execute it for me in the terminal, and I can see basically the output. Okay. So as you can see, when I execute the system, it's just running the ls port. Okay. But the point here is that it basically creates a new process, and after that, in the new process, I'm just executing the ls command. Okay. So by the system, so it must be clear. By the system, I just create a new process, and after that, I'm running the ls command. Okay. So another thing is just exec. Okay. So as I told you, okay, just I comment for you the different type of usage here, the usage of the exec and different from, but I'm just introducing you to just one of them. Okay, so for the exec command, the first argument was the binary file that I'm going to execute, I'm going to run, and then a list of the argument that I'm going to pass to the function here. But the first argument should be the same name of the name of the binary file. So as you can see here is ls, and then the list of the argument that I'm going to pass, but it should be terminated with null. So as you can see, I'm just passing one argument, and here as you can see, okay, the last is just a null. So it must be always the last should be null. Okay. And the first is just the name of the binary file, and in between, so you are passing basically the argument. Okay. Okay, this is comment. So we have also I put for you here the different types of the, but I'm not going to the details of them. So let's also execute this one. As you can see here, okay, when I run this, so again I will see the output of the ls command. But there is a difference between this one and also the system. So do you know what is the difference between this one and the previous example? So when I run, okay, so you will last one, okay. Otherwise you will answer to. Okay, so when I basically run the system, I will see this is the output, okay. But when I run also the exec, the output is the same. But what is the difference between these two? So when I run system,
you generate a child process from the parent that basically runs the ls command.
Okay.
While when you do execl, you basically remove in the code segment that of the parent and you replace it with a new program that is ls.
We are replacing basically the process of the ls.
You are cancelling the
not cancel. We are replacing.
Yeah.
Okay. So is that clear? So basically, when I use the system, I'm just generating. I have two processes. But when I use exec, I have only one process. Okay. The next thing is just like I suppose that okay. So it's okay. So I introduce the exec. I introduce the system. Yes. Okay. Okay, so also there is one example here for introducing the GUID and also GID and parent processes here. Okay, so by this basically, okay, I'm just simply printing out because this is itself is a one process, right? When I run this, okay, this is a process. I'm just, okay, this process, so I'm printing out the PID, the UID, GID, and PPID of this process, okay? Just very simple. And as you can see here, when I compile, and run, so it's printing out this is the process ID of the process, this is the UID of the process, and this is the group ID of the process, and this is the parent process ID, okay? So, because as you know, okay, so this is basically, we have the owner that this is Masood, and I logged into the system with this user and execute this basically process, so I will see basically this user ID, okay? It shouldn't be the same as here. It is just indicating, okay, which user is running this process. And the next thing is just, okay, so this process that this is my parent. But do you suppose, okay, who is my parent now? Is the bash, yes. Because the bash is just 2132. And so as you can see here, the parent process is 2132. Okay. Is that clear?
Yeah.
Okay, it was everything just for today.
Okay.